Polypropylene is a thermoplastic, and there's really two important temperatures when you deal with a material like that. There's what they call a melt temperature, which is typically where it's processed, and that's pretty high on polypropylene, and then what they call the glass transition temperature. And when you have a temperature in the environment that's below that glass transition temperature, the molecules, the chains, are all pretty frozen in place, so it's sort of rigid and brittle. But with polypropylene, that glass transition temperature is on the order of about 20 degrees below zero C. Right, so if we're outside, you know, you're talking about freezing, you're talking about 0 degrees C, somewhere around there, it'd be perfect. But when I hear you say you're going to have like it's going to fold out, it doesn't have that kind of flexibility unless the design you make is going to be made like with slats, like this, and then a hinge between them or something. Then maybe you could get away with that.
Okay.
There's been a huge movement in the automotive industry, and specifically Ford, who's been trying to use more and more of just polypropylene in like the dashboards, the interior surfaces of a car, and for the big reason that it's much easier to recycle. What they have used in the past is ABS, and that's got some really good properties to it, and holds up pretty well in all different types of weathers, but it doesn't lend itself very readily to being recycled. There's really 3 different polymers that make up ABS, you know, that's why the acronym. Whereas versus polypropylene, it's what they call homopolymer. You know, you can just chew it up, grind it up, and reuse it again. So it is something that's showing up more and more, and like I said, Ford here in the U.S. is leading the use of seeing that more and more inside the vehicle. The other important issue for you here for something like that is that all thermoplastics are good insulators, good electrical insulators, good heat insulators. So you know it'd do a pretty good job of insulating.
Does polypropylene have an effect on plants?
I don't know the answer. I think an organic chemist might be the best person to ask. But normally we would think of those kinds of compounds as pretty inert, so not reacting with plants at all. Okay. And that's been used very commonly in the plant industry for a long time. So I think that if there was a negative effect, it would probably have been identified by now. So my best answer is I don't know, but I'm going to say most likely not.
Okay.
So I'm sure you guys have had like a general biology class, and you know the inside of a plant cell is kind of this liquidy matrix, and on a cellular level what happens is that just freezes, and you know things will expand a little bit, and sometimes there'll be like this freeze-thaw going on, and eventually that could actually just break right through the plant cell wall. So if you've ever seen stuff that kind of, you know, like, I don't know if you have a garden or not, but if you've ever seen plants that are still on the vine, or fruit that's still on the vine and it's been frozen, often it's kind of soft and mushy, and that's because, you know, the cell walls have kind of been broken down, and there's like this kind of gelatinous stuff inside, so it's going to destroy the cell. It's a big deal. The biggest deal, we said annual vegetation loss, so I don't know if you're including things like citrus crops or anything like that. I would say the biggest issue is probably in the citrus industry, and obviously this is going to vary crop by crop, and it's also going to vary by the time of year. So a spring frost can be a really big deal because you have trees budding out or plants just coming up, and you have this, sometimes maybe that'll happen really early in the year, and plants will get tricked into growing, and then you get this frost. That's a big problem. And frost is a big problem in the citrus industry. So I'm sure you've probably even seen on the news, oh, there was a big frost, your oranges are going to be really expensive, or, you know, orange juice is going to go way up in price. I would say it's in the hundreds of millions of dollars.
In general, it's pretty durable. It does have a few structural features to it that make some things particularly troublesome. So its structure has tertiary hydrogens on it, which means it's susceptible to degradation in the sun. So you definitely need to have ultraviolet stabilizers in your polymer mix, and also it gets brittle around 0 degrees C, so freezing temperature. So if there are a few things you can do to make it resist breaking by adding, for example, small pieces of rubber in the mix will actually allow it to dissipate some of the heat when you hit, or the energy when you hit it, and support that so it's got better impact strength. And also you can orient the molecules in it by drawing it as you're forming it, which might work well for a film. So those two things would give it some additional stability in that. The colder down you go, the more brittle it would get potentially, so you might have some issues. Well, right now it's about 30% of the industrial polymer market. It's been gaining somewhat over polyethylene for a number of reasons. Plastics in general are in kind of a position where things are getting a little bit more difficult because most polymers come from a petroleum feedstock, and so as the price of oil goes up, so does the price of the polymers, and also the price of getting the polymers to where they need to go, and the price of getting the materials you need to make the polymers. So it's getting harder to turn a profit in some segments of the polymer industry. But I believe that the material properties are such for plastics in general and polypropylene that they're going to find a way. It may be that you need to consolidate into larger and larger suppliers, and therefore you get the economy of scale working in your favor. But I think it's going to be around for a number of reasons. It's a fairly cheap relative polymer to other things and has good properties.
Okay, yeah, we were just wondering too, what would happen if it rained?
Polypropylene is not very permeable, which means it doesn't allow even gases to flow through it very well. If you do that orientation thing where you stretch the material, you can increase the permeability a little bit, but the rain would pretty much slick off of that material, or puddle in it if you didn't have it at an angle.
Okay.
So.
And then just the last one, do you see the use of polypropylene as a realistic application for the garden cover?
I think there are some engineering challenges you would have to overcome. For example, the impact strength, if you want it to be used around frost temperature, you're definitely going to have to modify the properties to allow for that. But I think it is something that you could definitely engineer to that use. There's a lot of things you can do by making it a copolymer or doing other things that will change its properties slightly, that would give you a better mix of things. So maybe you can't get away with strictly polypropylene, but maybe a mixture of polypropylene and something else will get you where you need to go to have the flexibility to roll up, but the impact strength in case something falls on it while you're protecting your plants with it.